Welcome to the water calorimetry lab, also known as the hot-cold water lab. This lab's got 3 parts. We'll walk through some of the setup and then you'll work on making the data table based off of the data given to you in the videos. It may vary slightly from the data that you see here on the sheet. Basically, we're going to take cold water and hot water and mix them together and see what we get. Some data that you're going to need. 1 milliliter of water is equal to 1 gram of water. That's a very important piece of data. For all of these data sets, you're going to be looking at the mass of the water, the specific heat of the water, the temperature final of the water, and the temperature initial of the water. That data is needed for cold water, and it's also needed for hot water. So I can just be fancy, and I can copy this, and I can paste this over here. Okay, so I'm going to have hot water and cold water data for these. We'll fill these data tables out as we go through the lab using the data given to us in the video. Here's our part 1 of the water calorimetry lab, also known as the hot-cold water lab. Here's our setup. We have our probes with 2 probes in them. I have a probe that's going to read the hot water temperature, and I have a probe that's going to read the regular room temperature water. I have a cup just nested in a beaker so it doesn't fall over. I have a graduated cylinder, an empty beaker that I'm going to use, and cold or just regular tap water out of the cold tap. For part 2 of the lab, we are going to use 100 grams of cold tap water and 200 grams of hot tap water. The procedure remains the same. You'll notice we used a larger cup just to hold the larger volume of water being used. 3, we will have more cold water than hot water. We will have 100 grams of cold water and only 50 grams of hot water. Okay, let's walk through one quick calculation, and then you should be able to do the rest of them. So here's part 1. We'll look at part 1A. It says calculate the total heat of the cold water. So we'll be looking at this data right here. The equation Q equals MC TF minus TI, or delta T, however you want to say it. It says we're solving for total heat, so we're going to solve for the Q. We're given a mass of 100. We're given a C of 1. And again, I'm getting all that data from right here. Okay. And T final 38.3. T initial 22.5. Pull out my trusty calculator. I do what's in the parentheses first. 38.3 minus 22.5, 15.8. I multiply that by 1 and by 100, 1580. Okay, so my Q is equal to 1,580 calories. Now that you have that, you can walk through, same deal, calculate for hot water and then compare. Move down, calculate for cold water, hot water, repeat. So that's all you're doing.